In this video, we will learn about ozone layer and its depletion. Ozone, whose formula is O3, is a pale blue colored gas which has a peculiar pungent smell. Nearly 90% of the Earth's ozone is situated in the stratosphere, the layer of atmosphere between 10 to 40 kilometers above the surface of Earth. So this is troposphere, this is stratosphere. So maximum ozone is situated in this region here. So this is the region where ozone maximum or 90% of the ozone is situated. Now, how ozone is being formed? So, ozone in the stratosphere is simply a product of the interaction of UV radiation with oxygen molecules. Here, oxygen, which is O2 gas, on interacting with UV radiation will get converted into atomic oxygen and oxygen atom. So here we have one oxygen atom and other oxygen atom. This was oxygen molecule. Now it is being converted into two oxygen atoms. Now this one oxygen atom will further react with any oxygen gas molecule and they'll form O3, which is our ozone. So ozone, which is O3, is thermodynamically unstable. It absorbs UV radiation and gets decomposed to give back oxygen. So here this is the reaction, as we are able to see that this arrow is showing that the reaction is reversible, which means that ozone sometimes will dissociate further into oxygen and again back to the oxygen atom. Now these oxygen atom will further react with another oxygen atom to form oxygen gas. So ozone is continuously being generated and destroyed by UV radiation, and a dynamic equilibrium exists between the formation and decomposition of ozone. Therefore, the overall amount of ozone in the stratosphere is essentially constant in a natural cycle. This has been true for millions of years. Now the impact of ozone layer. The layer of ozone in the stratosphere absorbs UV radiations coming from the sun and prevents most of them reaching the earth, and thereby shielding life on the earth from the harmful effects of UV radiation. Hence, stratospheric ozone is called as good ozone. Now the depletion of ozone layer. Since some decades, according to atmospheric analysis and measurements, the ozone layer is getting thinner and depleted. The depletion in the amount of ozone has been most severe at the poles over Antarctica. According to scientists, certain man-made chemicals are the major contributors to this problem. These substances are called ozone depleting substances, ODS. These are mainly chlorofluorocarbons, which are CFCs. They are also known as freons, which are used as refrigerants, blowing agents in foam industry, and cleaning agents in computer industry. Since World War II, CFCs have been widely used. Freons are non-toxic, non-inflammable, and extremely stable chemical compounds. Means they don't react with the oxygen present in the atmosphere. So they are rather chemically inert and do not dissolve in rain after being released into the atmosphere. So they mix up with the atmospheric gases. Then they will be carried by the winds and they finally reach the stratosphere without being modified because of their inert nature. Then in the stratosphere, they finally get broken down by the powerful UV radiations, releasing chlorine free radicals, etc. For example, CF2Cl2, which is a freon 1,2, on its exposure with UV radiations, we will get a chlorine free radical along with the side byproduct of CF2Cl free radical. This chlorine free radical then further reacts with the stratospheric ozone to form chlorine monoxide radical and oxygen gas. So this is we have the reaction of chlorine radical with the ozone gas, and finally we will get chlorine monoxide radical and the oxygen gas. Then the reaction of this chlorine monoxide radical with atomic oxygen finally produces more chlorine free radicals. Here is the reaction we have. Finally we will get chlorine radical and the oxygen gas. Thus, the chlorine free radical that destroys ozone is regenerated at the end, and therefore a single chlorine free radical destroys millions of O3 molecules, which eventually result in the depletion of ozone layer. Other chemicals responsible for the depletion of ozone layer are methyl chloride. They do in the similar way as well, just like we just saw the CFCs. Others we have methyl chloride, methyl bromide, carbon tetrachloride, bromofluorocarbons or halogens, methane, which is CH4, and nitrous oxide. Ozone hole. As early stated, the depletion of ozone has been most severe at the poles, especially over Antarctica where a seasonal ozone layer hole appears. The Antarctic hole was discovered in 1985 by British scientists. Technically, it's not a hole where no ozone is present, but it is actually a region of exceptionally depleted ozone in the stratosphere. I hope it is clear to you. Thank you.